Welcome back to Mezone African Motifs. We are still on our analytical geometry. So this is going to be a continuation working with the inclination of a line. We just need to know our basics on this type of a question, on these typical questions that we are given. So I'm just going to go through from what we are supposed to actually understand in the angle of inclination of a line. All right, so we're just gonna have this, the inclination of a line. What is it that we are talking about or that we are referring to? The inclination of a line. Let us consider to say you are given a Cartesian plan. Remember all this where it is being taken from. We've got our x-axis, our y-axis like this. At a condition that a line can be drawn, let's say you've got line AB, you've got whatever line that you can call. All right, that line is being drawn like this. We must understand that all these lines that you see in this manner, all right, they are increasing. Like if you check with the x values, remember x values are going this side. So as you're moving 1, 2, 3, 4, 5, 6, and so on, you are going to see that the y values are also increasing in values. The y values are increasing. So on a condition like that, that the x values are increasing, the y values are also increasing, like what we see here. The gradient, which is referred as m, remember m for the gradient, is going to be a positive throughout. All right, we are going to have a positive gradient on these lines. So whenever you calculate your gradient on a line like this, it must be positive. Always, whenever you of this nature, the slope of this nature, all right? Because we have got the opposite of this nature. Let us consider this one. We can have these lines drawn this way. I want you to see this way. If a line is drawn in this way, it has got a negative gradient. Let us consider what is happening with the x values. Let's say this is 0 here. This is 1, 2, 3, 4, and so on. I want you to see what is happening. When x is at 0 here, look, the y value is bigger. At 1, the y value is becoming smaller. At 2, the y value is becoming smaller, 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 and so on. As the x values are increasing, 1, 2, 3, it's an increase, this one. X values are increasing. But what is happening with y values? The y values, they are decreasing. There is a decrease. There's an increase in x, a decrease in y. So on that one, as you can see, it's an opposite to one another. So we are going to have a negative gradient. That is where it is coming from. So whenever you calculate the gradient of a line of this nature like this, with a slope of this nature, it has got a negative gradient. Okay? This is something that you are supposed to understand or to know in your simplifications. So like I said, these lines, they have got a negative gradient. Okay, so these ones have got a negative gradient. What about these ones? They have got a positive gradient. So I'm going to talk from there. Now that we understand how these gradients are related in our lines, we also need to understand this angle of inclination on each line that we are given. For a line that has got a positive gradient, this is what is going to happen. We've got something of this nature, and our line has got a positive gradient. I said end line of this steepness or whatever, as long as it is going this side. All right. All these lines that you're going to see like this, as long they've got a positive gradient, as we mentioned before. The angle of inclination being the angle that is found between the line and the positive side of the x-axis. Take note, between the line and the positive side of the x-axis. If your line is this side, this is your line, this is the positive side that we are saying, to the right side of the x-axis, to the right side, not this side, but to the right side, this way. So this is your angle of inclination. Let's say we call it theta. Maybe it's beta, maybe it's alpha. These are just angles that you're talking about. So this angle theta, you are going to see as long you have a positive gradient like what we see here, it is going to be an acute angle, this one. It's going to be an acute angle that we are talking about. Always, whenever you have a positive gradient, the angle theta between there is an acute angle. Remember, we are talking about an acute angle, an angle that is, if you're talking about this theta, if it is an acute angle, our theta must be greater than 0 degrees, but less than 180 degrees, I mean. So that is, let us consider 90 degrees there. Sorry for that. Remember at 180 there, we are now talking about the more than 180, more than 90, but less than 180. We are now talking about what? An obtuse angle. So at 90 degrees, it will be a right angle. More than 90 degrees, less than 180, we're now talking of what? An obtuse angle, okay? So this is your acute angle, an angle that is in within these two. That is the type of angle that you're going to have there. So how do I calculate this theta that I'm talking about? So it follows that the gradient of L, if you have, because this line is got, that's why I was talking about the positive gradient. There is a gradient that we calculated there. So given our gradient as m of this line, it follows that the tan of theta is equal to the gradient. So m, which is our gradient, is equal to the tan of theta. So since we want to talk about this theta, we can just write it this way. The tan of theta is equal to m. So it follows that if I want to calculate this theta, remember from your trigonometry, if you are given, let's say the sine of x is 0,5 and you want to calculate for x, what were you doing? You were calculating first what you call the reference angle. First, the reference angle, which is the arc sine of 0,5. You're calculating the reference angle. Then you relate with the quadrant to say, okay, in the first quadrant, this is what I have. In the second quadrant, this is what I have according to the actual angle x. If it is in the first quadrant, we know that from this, in the first quadrant, all right, this is first, second, and so on. In the first quadrant, your x is going to be equal to the reference angle. If it is in the second quadrant, your x is going to be equal to 180 minus the reference angle. That part is playing a role. Your x in the first quadrant was going to be equal to the reference angle. What types of angles lie in the first quadrant? These are acute angles. In the first quadrant, you're talking about an angle that is in between 0 and 90. Between these two. So in the first quadrant, you're talking about an acute angle there. So if we are talking about an acute angle, it follows that. That is why we are going to see that this theta that we have, the theta that we are going to talk about here, it is just going to be equal to arctan of m. In actual sense, we were supposed to calculate what is called the reference angle, and that reference angle is called arctan of m, which is arctan of what? Of the gradient that you're given. And after calculating the reference angle, your theta is equal to the reference angle in the first quadrant. Why am I so sure that this is in the first quadrant? It's an acute angle that I'm talking about. That's why I wanted you to know this. You have an acute angle that you're talking about there. So this is where it was actually taken from. So the theta is equal to the reference angle in the first quadrant. So that is why in the as long as you've got a positive gradient like this, your theta is arctan of the gradient that you're given. But why is it that you have to make adjustments when our line is having a negative gradient? Whenever our line is now having a negative gradient, so this is a condition when you have got a positive gradient. Whenever you've got a negative gradient, this is going to change, all right? So this is now like this. Like I said, whenever this gradient is negative, our line, the slope of this is going to change. So this is what we are going to have. We are going to, these will be our lines. They will be of this nature, where X and Y are not in the same manner. X is increasing, Y is decreasing. That is the condition. So let's say we've got a line of this nature. I want you to be careful now. The angle of inclination, its condition does not change. That is, it is taken between the line and to the right side of the x-axis. All right. So it must be between, all right, between the line and the right side of the x-axis. And the right side, which is the positive side of the x-axis. Always, it must be the positive side, the right side. So this is the line between this line and the right side of the x-axis. This is the right side, all right? So this is your angle, this one. So as you consider this angle that we are talking about, this angle here between the line and the positive side, which is the right side of the x-axis, let's say this is our theta. In our trigonometry, we understand that this theta that we are talking about is no longer an acute angle. It is no longer an acute angle. This is now an obtuse angle. And an obtuse angle, if we are to relate its conditions, how it maintains its conditions, it is an angle that is going to be dropped or that is going to lie in the second quadrant. Always, because this is it, guys. This is 0 degrees here. This is 90 degrees. This is 180 degrees. This is 270 degrees. We are back to 360 degrees. So talking about an obtuse angle, we're talking about an angle. If theta is an obtuse angle, it must be greater than 90 degrees, but less than 180 degrees. That's an obtuse angle. So if this is truly an obtuse angle that we are talking about, it means it is an angle that lies in the second quadrant. And what are the conditions for the second quadrant? X, if X is the exact angle, or if X is the angle that we are supposed to calculate, it is equal to 180 minus the reference angle, whereby the reference angle is the one that you just calculate arc sine of this, arc tan, arc cos, considering that you ignore the negative. So this is what you're going to do. The reference angle, as usual, you know that you are going to ignore the negative. Remember, this has got a negative gradient. So if we're saying m, which is the gradient, is equal to the tan of theta, which is true. The tan of theta, maybe it's 145 degrees. I want you to see what's going to happen. Or maybe it's 135 degrees, whatever angle that you might be given. Whatever angle that you might be given. Let's say I've got a 135 degrees. I just want you to see something here so that we'll be together in this introduction. Let's say we've got tan 135 degrees. This is an angle that is greater than 90, but it is less than 180 degrees. All right. So sorry for that, guys. You see, these softwares. All right, this is -1. That's a -1. Are you seeing that? It's giving us an exact negative, meaning to say that is exactly what happens or n obtuse. All right, let's just take any angle greater than 90 degrees. Let us just say 95 degrees. Okay, that's a negative again. Anything that you want, the tan of maybe 100 degrees, it's a negative again. So whenever you have this negative, whenever you have an obtuse angle, your m is going to be negative, which is the gradient is negative. But this is it now when you want to calculate the angle of inclination. You have your gradient and you understand that the tan of theta is equal to m from this part. You understand that. And now you want to calculate the theta. It follows that because this is a negative, remember, this is a negative value. So what you're going to do is to ignore, just like in your trigonometry, when you're calculating the angle, all right, given tan of x is equal to minus 0.5 or whatever that you're given there, you ignore the negative that you're given, all right? So you ignore the negative sign that you are given. And what are you going to do? You calculate the reference angle, just like what you had there. You calculate the reference angle. All right, the reference angle. In this case, you're just gonna write RA for the reference angle. So meaning to say, in this case, the reference angle is going to be equal to the arctan of M with a positive. This one is now a positive because we had to ignore the negative sign. The negative is just there to show us that it lies in the second quadrant because it's an obtuse angle there. So after that, you are going to calculate, you're going to obtain a certain angle. That angle that you're obtaining, which you are calling the reference angle, this is the angle that is found here. This is the angle that is found at this point here. This is your reference angle. This is the one that you just calculated from this. So to find the theta now, which is the exact angle that we want, it is going to be 180 degrees minus the reference angle. Remember the condition of the second quadrant, 180 degrees minus what? Minus the reference angle in the second quadrant. In the first quadrant, x is equal to the reference angle. That is why here our theta was equal to arctan. There's no adjustment. There's nothing. Whatever that you get there is your answer. But on a negative gradient, you make adjustments because of this. This is how. This is where it was taken from. So your theta will be equal to 180 degrees minus the reference angle, which is the angle that you calculated from arctan of the gradient, but ignoring the negative sign, meaning to say arctan of a positive. Okay, let's take this into consideration in these questions because it's all about calculating the angle of inclination. We are given, determine, all right, the first part, the angle of inclination of the line AB where the gradient of AB is given. This is what you're given. These are the gradients. The gradient of the line AB is 2. The gradient of line is minus M, remember, is the gradient. So let us take the condition that we are given in the first part. We are given M is equal to 2, 1.1. M is equal to 2. 2 is positive. This is a positive gradient. So when it is a positive gradient, I don't need to know the line is like this. The line is going to be this side. The line is going to be this side. The line is going to cross here. The line is going to, I just know that this is a positive. The line is of that slope. And when it is a positive like that, my theta is an acute angle. So it follows that the tan of theta is equal to 2. And theta is equal to what? Theta is equal to arctan of 2, where it's a positive. It was actually theta is equal to the what? To the reference angle, which is arctan of that. So don't even mind when it is a positive like that. So your theta is just arctan of what? Arctan of 2. So it's now you and your calculator. So let us just have our calculators here. So this is arctan, which is shift tan 2 like this. Okay, so that will be 63.43 in that. So you can actually round off to 2 decimal places. That's shift. You go to the setup, then you can fix this. All right, just fix to 2 decimal places. That will be 63.43. So that is 63.43 degrees. All right, this is an angle that you're talking about. So as long it has got a positive gradient, remember what I said, as long it has a positive gradient, your theta is equal to arctan M. There is no adjustment that you're going to make. But when it is a negative like that, our M is a -5, our gradient is a -5, we have to consider this condition that we are given here. We have to consider this condition that we are given here. So our M is equal to -5. Like I said, you ignore the negative because we understand truly that tan theta is equal to gradient, which is -5. But the theta, the moment that you are guys, to calculate for theta, to calculate this theta, it is to solve for theta. You are solving So you are back to your trigonometry. You don't just calculate theta, you are solving for theta. So to solve for theta, in the actual sense, what were you doing? You were going to ignore this negative. You calculate the reference angle, which is arctan of this value, which is arctan of 5. So our reference angle in that case was going to be arctan 5. All right, let us also have this. So remember, our calculator now is fixed to 2 decimal places. So whatever that I'm going to have will be to 2 decimal places. So this is arctan 5. 78,69. So that's 78,69 degrees. This is not our theta. No, this is the reference angle. The theta, which is the exact angle that we are to solve, that we are to find, which is the angle of inclination, it is going to be 180 degrees minus the reference angle, which is minus 78,69. That is exactly what you need whenever you've got a negative gradient. All right, so there we've got 180 degrees minus the reference angle, which is 78,69 degrees. So this will give us our answer to 3 decimal places, to 2 decimal places, I mean, which is 101,31 degrees. All right, are we not given instruction here? We are not given instruction. Sorry for that. So let me just check what we got here so that we'll move on together. All right, so this is actually 1 decimal place. Like, guys, let us just maintain that. All right. So in this case, if you're to use 1 decimal place, you're going to have 63.4. If you're to use 1 decimal place, this one, you're going to get something like 101,3 if you're using 1 decimal place. But if you're using 2 decimal place, this is what you're going to have. All right. Since you are not told about the degree of accuracy on the you are told on the second one, but on this one, you're not told. All right. So that is the condition that you're going to have. All right. On number 1.3, our gradient is now 5 over 3. So this is not going to change because it's a fraction. No, that is not going to change as long as a positive like that. This is just going to be what? Theta is equal to arctan of what? Of the gradient that you are given there, which is arctan 5 over 3. You obtain your theta. That is how you are supposed to have this. And arctan of 5 over 3 was going to give us something like 50.04 to 2 decimal places. 59,04 actually to 2 decimal place. If you have got a negative, you do that same condition, whether the decimal does not matter, you find your reference angle by ignoring the negative, then your theta will be 180 degrees minus the reference angle, just like you are solving your normal trigonometric equations. So I want you to try that and see what you're going to have. Must have something like 144,2 degrees to 1 decimal place if you're to maintain the 1 decimal place concept. All right, so that is the condition that you're going to have as long you are working with the gradients that are given. So if you check on 1.2, they want you to do the same thing to determine the angle of inclination of these lines correct to 1 decimal place. You're given now a condition to work with. So the condition does not change. We just need to know the gradient. So when I'm given an equation like this on 2.1, where y is equal to half of x minus 8, how do I know the gradient? Because the angle of inclination is bound or is controlled by the gradient. So if it is controlled by the gradient, I need to know the gradient of this line. Remember, whenever the line is written in the form of y is equal to mx plus c, the m represents the gradient, which is the number that is multiplying x, the coefficient of x. And in this case, the coefficient of x is 1 over 2. So we are so sure that our gradient is 1 over 2. By knowing the gradient, we know the angle of inclination because we understand that this is a positive. So therefore, theta representing the angle of inclination is going to be arctan 1 over 2. And therefore, our theta from there, we are not going to make any adjustment because it is a positive gradient that we have. That is going to give us 26,6. That is 26,6 degrees, all right? So if you were having your calculator now to 2 decimal places, first thing is to change that. So you're going to have shift set up to fix again to 1 decimal place because our answers are needed to 1 decimal place, all right? So this is arctan 1/2. So our answers are now to 1 decimal place. So, all right, arctan, guys, arctan. Why is the shift not there? Okay, that's arctan. So you must see a negative there. You must see this one. This negative must be there for an arctan, all right? Arctan 1/2 like this. So this is 26.6 degrees. So that is your theta, what you are going to have in this condition. So if you are to consider the second part of the line, again, we just need to write our, we just need m, which is the gradient. From the equation that you are given, you need m. So if you have to consider this, that is 2.2, you are given the equation 5y plus 2x is equal to 10. So if we are to consider y is equal to mx plus c, what is it that you must have? You must have y as the subject of the formula. So we can transpose the 2x first to the left, to the right-hand side of our equation. That is 5y is equal to minus 2x. It was a positive. The moment it crosses the equal sign, it must change its sign. So that is minus 2x plus 10. I need y, not 5y. I need y is equal to, y is supposed to be the subject. So I just have to divide by 5 each and every term. So if I divide by 5, y is equal to minus 2/5x plus 10 divided by 5, that is a 2. So here I'm not worried about this constant. I'm worried about the part that is affecting x, mx. M is the part affecting x. And what is affecting x is this number, which is negative 2/5. This is your gradient. So your gradient is negative 2/5. So it's just like this condition where you were given a gradient of -5, a gradient of minus 0.72. How were you calculating the angle of inclination? Because you now have the gradient. So it follows that with a negative, remember what I said, if the tan of theta is equal to the negative 2/5 that you're given, which is your gradient, then to find this, you have to solve first for the reference angle, which is just arctan of this with a positive. You ignore the negative, you determine your reference angle, all right? So that is the condition. So let us see what we are going to have in this manner. So this is simply arctan 2/5. So arctan 2/5, what are we going to have? That's 21.8 to 1 decimal place, 21.8 degrees. So therefore, theta, which is the exact angle, is 180 degrees minus the reference angle. You subtract your reference angle, and this is going to give us what? If we are to subtract 180 degrees minus the reference angle, which is 21.8 degrees, this was going to give us 158.2. So that's 158.2 degrees. So you consider first the equation that you're given to say, what is the gradient? Because you have an equation that you're given. What is the gradient of that equation? From the gradient of the equation, once you've got the gradient, you have the angle of inclination. You just have to consider, all right, is it negative gradient? Is it a positive gradient? You're still back to that same consideration that you worked with in the previous case. So if you're to consider the third line, you are given y plus x, which is equal to 3. So here you just have to transpose x to the other hand of the equation so that it will be minus x plus a 3. It was a positive. So on this side, it will be a negative x. So if we are to consider this is minus x. There is a number that is given there. If it's what? Invisible. There is a -1 there. So it means our m is equal to -1. M representing the gradient. Once I know that the gradient is -1, now I'm going to find the reference angle, which is arctan of what? Arctan of the one, which is a positive. Ignore the negative. All right. And you're going to obtain something like 45 degrees from there as your reference angle. Therefore, a theta, which is the exact angle, is 180 degrees minus the reference angle. And that was going to give us 135 degrees. So these are the typical questions that you might have actually in an exam. You just have to consider your simplification. Given the points P, Q, R, and S. These are the points that we are given forming a shape or a quadrilateral that you're given on this Cartesian plane. So from these points that you're given, determine correct one decimal place the acute angle between QR. All right, the acute angle between QR. This is the line angle. The line that you're given. So they are saying the line QR. This is QR, this one. QR. This line has got a negative gradient. Without even calculating, you can see there's the slope. It has got a negative gradient. So they are not asking you to calculate the angle of inclination. No, the acute angle is not the angle of inclination. It's just an angle that they're talking about. So you must know your angles. This is your line QR. The angle of inclination is between the line and the positive side of the x-axis, which is this one. This is not an acute angle, this one. If this is theta representing our angle of inclination, we are not talking about this. We are talking about this one that is on the other side. This is the acute angle. They are talking about the one that is on this one, which is the reference angle. They are simply asking you for the reference angle of this line. Remember what I said when I was introducing, this is the reference angle, then theta is going to be equal to 180 degrees minus the reference angle, which is the angle of inclination. Theta is the angle of inclination. But this acute angle they are talking about is not the angle of inclination. According to QR, this is the acute angle, the side where the acute angle is. And that is not, because I said the angle of inclination is between the line and the right side of the x-axis. And the angle formed between the line and the right side of the x-axis is not an acute angle, this one. All right, we talked about these types of lines with the negative gradient. And still, I think you still remember that. All right, so with this, we were going to calculate the gradient first because we're just given points. There's no way we need the gradient in this case. All right, so let us talk about QR. In that case, we need its gradient. So that's 3.1. All right, so considering the line QR, we are going to need the gradient. Remember, we talked about how to calculate the gradient of a line from the change in y over the change in x, y2 minus y1 over x2 minus x1. So considering your points, you can just call this x1, y1, and this is x2, y2. So the y2 value at this point can be taken as -5 minus the y value, which is 2, over x2, which is the x value, which is 7, minus the x value here, which is a 4. So this is going to give us the gradient. So there you can just also simplify on your calculator if you want this. All right, and also just avoid, because the fixing that we did was to make sure this is to 1 decimal place. So now we just need a proper simplification. So go back to the normal mode. That's press 8, then press 2. All right, so your calculator is back to the normal mode. Then you can simplify -5, -2, everything over -7. Sorry, that's a 7 there, not minus, that's a +7, -4 like this. And that was going to give us -7 over 3. So this is the gradient, -7 over 3. Like I said, as you can see, this is a negative gradient. And by default, this angle of inclination that we are given is supposed to be an obtuse angle. So this is not the one that we are talking about. The one that we are talking about, which is the acute angle, is this one, that is this other side, which I said it is our reference angle. So in this case, since you have got your gradient, you are simply calculating the reference angle, which is the reference angle is arctan. When this is taken as a positive, you ignore the negative that you're given there. You ignore it, and that answer will be a positive. So that is arctan, which is shift tan, 7 over 3 like this. All right, so to 1 decimal place, that will be 66,8. All right, shift again, fix this to 1 decimal place. That is going to be 66,8 degrees. So this is the angle that the question is asking you about, which is the acute angle. This is the acute angle the question is asking you about. The question is not asking you about the angle of inclination. If it was the angle of inclination between PQ and x-axis, it was this one on the positive side of x-axis. And that one, they could have said the obtuse angle. If they said the obtuse angle and you consider your diagram, you see, okay, according to my diagram, truly it is the obtuse angle and that is the angle of inclination. But in this case, they wanted you to calculate the reference angle, which is 66.6 degrees. So this is the angle that we are just seeing here in between here. It's 66.8 degrees. Sorry, this angle between here, that is between the line and this other side. Okay, that is what we have. If we are going to need the angle of inclination of that line, we are going to calculate it. But according to this one, they are not asking about that. Please be careful how you answer your questions. All right, 3.2, the angle of inclination of PQ. All right, this one, they need the angle of inclination this time. They need the angle of inclination this time of what? PQ. This is the line PQ. This is P, this is Q. We are talking about this line here, PQ, like this. So which one is the angle of inclination? Remember I said the angle of inclination is the angle that you are going to find between the line and the positive side, which is the right side of the x-axis. This is the line, and this is the side, the positive side of the x-axis, which is the right side of what? The x-axis. So the angle formed is this side. That is the angle there. So we are talking about this angle between this line, the x-axis, just an angle. There's an angle there that is formed, this one. All right, let us just indicate this way, this one. This is the angle that we are talking about. So maybe we're just going to call it alpha, all right? Whatever way that you're going to call it. So we need also the gradient of PQ in order for us to have this. And as you can take note of the slope, I said all lines of this nature, they have got a positive gradient. So if we are to calculate this gradient, you're going to see it is going to be a positive, all right? So that's 3.2. So the gradient, you're going to need the gradient of PQ in this nature. So like I said, from our formula, y2 minus y1 over x2 minus x1, you're going to consider, let's say you want to consider this as your y2, it's up to you, which is 2. So it's going to be 2 minus y1, which is minus 1, like this, over x2, you take this as 4, minus the x value on the second point, which is minus 1. All right, so this was going to give us the gradient of what? Of the line PQ, all right? So let us consider the gradient of the line. We're just gonna need the normal mode. Again, that's the disadvantage of this, but it's an advantage that you just have or obtain your answers direct. All right, minus minus is a plus. Don't worry about that. You can even write 2 plus, just like 4 plus 1. Okay, it's just one and the same thing. So our gradient was going to be 3 over 5. So this is the gradient of PQ. As you can see, it's a positive gradient that we have. And I said, when it's a positive gradient like that, do not worry about anything. Your theta is equal to arctan M as it is, which is arctan 3 over 5, which is the solution, which is the reference angle. Theta is equal to reference angle in the first quadrant, which is an acute angle that you're going to have. So do not worry about that. So that is arctan of 3 over 5. Arctan 3 over 5 as it is on your calculator. That's to 1 decimal place. You're gonna have fix this to 1 decimal place. That's 31.0. That's gonna be 31.0 degrees. All right, so that is our theta, the angle of inclination. All right, so here I used as alpha, guys. I'm just gonna write alpha. Sorry for that. So let us just have this as alpha, since I wrote this here as what? As alpha, so that we just differentiate these angles. So our alpha was going to be 31.0 degrees. This is the angle between this line and the positive side of the x-axis, which is the angle between here. This is the angle that we are talking about. Okay, that's the angle of inclination, this one, and it's an acute angle. According to this line, it's an acute angle. So don't confuse with this one, this line that we had, this one. According to that line, the acute angle is this one that is on the other side. So do not confuse, please. All right, then at this point, they want you to calculate angle PQ. That's why they wanted you to calculate it. It's because of this. They want you to calculate angle what? PQR. Look where angle PQR is. All right, so it's unfortunate that I can't adjust any further than this. So let's hope you see properly on your diagram. So this is what is happening here. Remember, we got this angle between the line and the x-axis, and also the line and this side of the x-axis, which is this one of 66.8. And so it's forming a triangle like this. It's actually forming a triangle where this is Q, this is, all right, this point we do not know, but it's going to go there to P, then here it's going to go to R. But these angles that we calculated, they form a triangle. This angle here, which we calculated, which is 31,0, that is 31 degrees. And this angle that we calculated here, which is 66,8 degrees. They form a triangle. With these lines here, they form a triangle. And the angle that they want you to calculate is called PQR. From P to Q to R. The angle that we are talking about, PQR, is this one. Inside of the triangle, this one. PQR, this angle here that is formed there. So in a triangle, we understand that angles in a triangle, they add up to 180. So we can use the concept of angles in a what? In a triangle. If angles in a triangle, therefore angle PQR is simply going to be equal to 180 degrees minus these two angles that we are given inside of the triangle, 31 degrees plus 66,8 degrees. The angles inside of what? Inside of the triangle concept. So that was the case of this question. You are going to now also use your geometry part. It extends to also understand the properties of your shapes. All right, so this is 180 minus 31, which is 31,0, which is just 31 plus 66,8 degrees. So this was going to give us 82,2 degrees. So that's 82,2 degrees. So that was going to be our angle PQR. So that is how it can be like, right? So sometimes you can actually extend to that nature. So this is our angle PQR there, 82,2 degrees. So that if you add everything in this triangle, you must have 180 degrees. All right, then we move on to another part, which is 3.4, the angle of inclination of SP. So we've got to consider the line SP. All right, this is our line SP from S here to P. SP is this line. So if you are to extend this line, this is what you get here. Something like this. It goes something, maybe it's going to be, I don't know, somewhere like that. So the angle of inclination does not change between the line and what? And the positive side, which is the right side of x-axis. So it's going to be somewhere there. This gradient that, this line that we are seeing, it has got a positive gradient considering the steepness, how it is growing. This is how our lines are. All right, so let us just calculate our gradient SP so that we can see, is it positive or not? But you're supposed also to just consider from the line that you are given to just see. So the point S is given. We need the gradient of SP, and we're given the point S. This is 3.4. All right, so this is 3.4. So SP, so the point S, remember this is minus 3.7, and P is given as -1, -1. So you can calculate your gradient still using the same concept, x1, y1, this is x2, y2. So meaning to say the gradient of SP from y2 minus y1 is going to be -1 minus 1 minus y1. Our y1 is -7. So it's minus, okay? Over x2, our x2 is -1 minus our x1 is what? Our x1 is also a minus. So that's minus there. So if you're to consider faster, a minus and minus is a plus, a minus and minus a plus. So that guy, you can write it, you can have it like that, but your calculator does not even mind about that. So you can even use direct on your calculator as it is, or you can have it the way that you understand. All right, so let us put a fraction there. -1 plus a 7. Everything over -1 plus a 3. So this is -1 plus a 3. That was going to give us a 3. So the gradient of this line is a positive 3. So as you can see, guys, a positive, like I said before, this must be positive. So to have the angle of inclination, if our line is having a positive gradient, I said theta, whatever that you're going to have there, is just going to be exactly arctan of what? of the gradient that you're given, which is arctan of 3. So from this arctan of 3 was going to give us what? It's going to be 71.6 degrees to 1 decimal place, or you can just save it this way. That's 71.6 degrees. That is our angle of what? Our angle of inclination, the one that we are asked. The question needs you to calculate the angle of inclination. All right, then calculate angle SPR. SPR from S to P to R, this one. This is not an angle of inclination that you see here because it's not between the line and the positive x-axis or the right side of the x-axis. So we have to relate to any other information about our lines, all right? The understanding of our lines, understanding of our angles, considering your straight lines, considering your triangles, everything. You have to consider those properties now. They are supposed to play a role when it is like this. I just hope on this one you are going to understand me, because I'm going to make adjustments here because we do not have the angle of inclination like I said before. But let us consider this way. Like I said here you are supposed to understand me, and I just hope it's going to be like that. All right. So let's say we are to just draw, you see the x-axis. It follows that, let me put it this way so that you understand me here before I do these adjustments. It follows that on the x-axis concept, if you are given the x-axis and another x-axis, like you just say, these are my x-axis, like, all right, these two, they will be parallel to each other. If I draw a line horizontal, all right, and also this x-axis is horizontal, it means these two lines, they will be parallel. And we are now back to the concept of parallel lines. So there's something that goes to these lines. Now we talk of alternate angles, corresponding angles. This angle and this angle, they are corresponding angles. They are equal. All right. One is inside, one is outside. This angle and this angle here, they are equal, corresponding angles. This angle and this angle, corresponding angles, they are equal. This angle here and this angle here, they're equal, corresponding angles. So it's something that we can take into consideration because we do not have the x-axis. So we can only have it that way. So let's say we are to make an adjustment here. We just put our x-axis, let's say this way. Sorry for that. I'm just gonna make some further adjustments. Sorry for that, guys. I just want you to understand me. That's why I'm doing this. All right. So this is gonna be like this. Let's say we have drawn a line like this one. This line that we have just drawn now, it has the same properties as the x-axis, which is a horizontal line. It's also a horizontal line. So it follows that if we calculated the angle of inclination here, which is of the line PQ, remember, you calculated the angle of inclination of the line PQ, which is this line and this line, they are now parallel. So it means the angle here, which was 31,0 on the line PQ, is going to be the same as the angle of inclination of this same line, but with the x-axis. So you're considering the same line and the x-axis, which is the corresponding angle is this angle here that is above the line and the x-axis, like this one here. So we are considering like this is now your x-axis. So you're considering this angle that is at this point here. So according to my diagram, let's hope it's gonna be clear. So it means if this was 31,0, this angle also is going to be 31,0 degrees. Let us just say 31 degrees. If it is alpha like this is also alpha. The way that we wrote there, we're just going to write it as what? As alpha. Okay? With the same situation, I want us to consider what happened with the line P. This one, it was PS, the line PS. So the line PS, we've got the line PS going straight here. This is a line PS. There was an angle that we calculated between this line and the x-axis, which is between the x-axis. And remember, that was this angle here that we calculated for the line PS. All right, if you are to consider for the line PS, that is the one that we just calculated here, SP, which we got as 71,6. So if that angle was 71,6, it also follows that because we're going to have the corresponding angle concept. This is corresponding angle. This angle here is going to correspond with the whole of this angle. So it's actually taking the whole of this angle. If you have to consider it properly, it is even including the 31,0, which is the 31, is also part of that angle, is also involved in this angle that we have of 71,6. So let us just put it aside. This is 71,6. Like I said, my diagram now is a little bit concentrated here. So that is 71,6, the angle that we are seeing, the whole of this angle here. But we are still seeing that we have got something that is missing. If maybe we were to consider this one, properly this one, we're just going to consider this one alone. All right, if you were to consider this angle alone, that was another part that we were going to have in this case, all right? Because this one, it covers like everything that we have there. It actually covers everything. So this concept, I want you to see where it is from or where it is actually coming from, okay? So it means there you've got 71,6, this angle, but you see these angles, they do not help you because look where they are. They are limited up to this line here, up to this line, the one that we are having there. They are limited up to there. They are limited up to this line. They are limited up to here. This angle is remaining. So it means it is not going to help you to calculate this one. So I want you to see the proper sense of this. So the proper sense is that, or the proper meaning of this, it is that we are supposed to work with an angle that is supposed to give us exactly what is corresponding to this angle that is inside. So if you are to consider that, you are going to see that this was going to be the best. So I'm just going to erase this so that we understand each other. All right, you understand me, guys. Do not worry. You will understand me. So I'm just going to do it this way. Let me remove this so that you understand me here. All right, so this is what you're going to do. You are going to consider this line, all right? This line of PR, all right? Let me just properly extend this one. PR like this. Okay, like this. All right, so this is our line PR like this. Okay, extend that line PR like that. So if you have to consider this line, you are going to see that you have got your x-axis. So the angle of inclination between this line and the positive, which is the right side of the x-axis, was supposed to be this angle here. Let's say this angle is theta. It is the same angle as this one that is going to happen between also the same line and this angle, which is the corresponding angle, this one that corresponds between the line and the x, which is our theta, like this. This is the angle that you are going to have at the end. We are considering the whole of this angle as theta. You're considering the whole of this angle as what? As theta again. But if you are to consider that, you are going to see that the theta, this one that you are having here, this one, this theta that you are having here, this one that you are having, it is not covering up to this part of the line. It is not taking the part. There's this part that is also remaining here, this one. But the lucky part of it, or the advantage part of it, is a straight line, this one. So you can take a consider that angles on a straight line, they add up to 180. So let's say this is my alpha. I'm just going to have this as 180 minus theta. I have got this alpha here, which is the angle that we wanted from that angle that was remaining here. Remember, there was a line that we removed here of what? Of PS. It has got its own angle of inclination that I took here, this angle and this angle. So I'm going to put that one at the end. So let's consider these two for now. All right, so I hope for now we are almost there. We are almost there. You're going to understand me very soon. Just going to remove this. Sorry for that. All right. So this is it. So theta is from PS. So you're going to calculate theta, which is the angle of inclination from PS. Or if you do not want to waste time calculating this theta, just calculate what? Alpha. If you do not want to waste time, you calculate alpha, which is alpha is what? Alpha is this angle that we are seeing, which is the same as this angle, which is the reference angle. Alpha is the reference angle. Remember the relationship between theta and the reference angle. So you simply calculate the reference angle. The reference angle is equal to this alpha. So alpha is equal to the reference angle according to my diagram. Okay, this is vertical opposite angles concept. So do we have the gradient of PR? We never talked about this line PR before, remember? So you're going to need the gradient of PR. As you can see, it has got a negative gradient. So that's why we have to consider that reference angle concept. So remember I said the reference angle is simply arctan of the gradient that you're going to take as a positive, but you need that gradient. So talking about the change in Y over the change in X of the line, PR in this case, all right? So let us just write PR or RP, still one and the same thing, RP. So that will be the change in Y. Remember, this is Y, which is -5. So it's going to have -5 minus the Y value there. It was -1 over X2, that is 7, minus X1, which is -1 like this. All right, so this was going to give us the gradient of this line. So just bear with me, guys, because there we need to understand each other. There's an introduction, so I'm trying to explain that you understand me. Minus, that's a plus there. So that's +1, 7 + 1. So this was going to be -1 over 2. So as you can see, truly, we are obtaining a negative gradient. So as we are not worried about that theta, we are worried about the reference angle, because our reference angle is the one that is equal to alpha. So the reference angle is simply arctan 1 over 2. You ignore the negative that you are given there. So that is arctan 1 over 2 like this. All right. So arctan 1 over 2 is going to give us 26,6. So this is 26,6 degrees. So this is the angle that we are seeing here, alpha, 26,6 degrees, our alpha here. But remember now I was saying you have got the line PS, this one that you had before. This was your line PS. And the line PS, what it had was there is a gradient. And you obtain the angle of inclination, which was this angle. That was your angle of inclination, this angle here, which is the same as this angle that you're going to present here. So this is our angle of inclination, which is the angle between this line here, this part here that I just indicated here, this one. So I want you to see that if this angle here, which is from our PS, remember, SP, the one that we had here, it was 71,6. So if this angle is 71,6, the whole of this angle here, what is it that you are seeing now? What we are seeing is that the angle that we want to calculate, which is SPR, all right? The angle that we want to calculate, which is SPR in that case, is simply going to be taken from the straight line concept. Knowing that angles on a straight line add up to 180 degrees, I'm going to subtract the 71,6 between this line and this part here, just this piece alone, just this piece alone. That is 71,6 degrees. And this piece here of alpha, this side here, the one that I was mentioning, the 26,6 degrees. With this, we can calculate everything that we need. That is 180 degrees minus the 2, 71,6 plus 26 6 degrees like this. So this was going to give us 81.8 degrees. So this whole angle was going to be 81.8 degrees. That's our angle SPR. All right, so this is a procedure that you need to take into consideration. We just hope with time we're going to have more of these typical questions so that you properly understand. But that is the way that you're going to need. You consider that concept, all right, to say if a line is drawn, it's parallel to this line, so it can maintain also the properties of what? Of a parallel line. So the angle of inclinations that you calculated before can be used on that line as long you properly use the line that you're given. All right, then the last angle that they wanted you to calculate was angle PSR from P to S to R, which is this angle here, P SR like this angle here that we are given here. All right, so if you had to consider again, if we were to draw the same concept, we draw our our horizontal line here. This is what's going to happen. Let us just put it closer, just like this. All right, let's say this is a horizontal line drawn at this point. What was going to happen here was that, please be careful. There were going to be two angles because the angle that you need is this one. Let me present it this way so that you see or we properly have this angle together. The angle that you need, P, this is S, this is R. The angle that you need is this one that is here, this one. This is the angle that we want. Let's say this angle is, now that we've called all angles, guys. Okay, let's just call it PSR as it is. You are going to see that it is being affected by two angles. There is this angle that is between, because you consider the same way as the x-axis. So you consider this as your x-axis. So you also consider this as your x-axis. So you are going to see that there is an angle of inclination between this line SP, that is line, this one, between the line and the positive side or the right side of the x-axis, which is this one. And we calculated this angle before. We called it 71.6. So this angle was going to be 71.6. Let's say is theta. Theta is equal to 71.6 degrees. You were also going to need the angle of inclination from the same positive side of the x-axis, but between the line SR, because the line, there's a part of SR that we do not need. So we need to remove this part of SR, this one. So let's say this is alpha, the angle of inclination of SR. Have we calculated this angle of inclination of SR before? No, we haven't calculated anything about SR before. So what it means, we are going to need the gradient of SR so that we have the angle of inclination of that. And with that, we can simply subtract the two. Okay, that's it there. PSR, which is 3.6. Okay, let's see. So that's 3.6. So we are going to do it like this. There are so many ways that you can actually have this, but for the basics of understanding, let's consider that way. So alpha is equal to arctan the gradient of this line, which is SR, all right? So we need the gradient of SR in that case. So we are going to calculate the gradient of SR. Remember our gradient from the change in Y over the change in X concept. This was going to be from the line SR. That's our point S minus, remember our point S was -3, -7. Now it's concentrated here, -3, -7. So it's gonna be SR. SR, guys, we never calculated this. -5 -7. So it's -5 -7 over x2, which is 7, minus the x value there, which is a -3. All right, so this is how you're going to have the gradient. So this, let's quickly have it and see. And it's going to be a positive gradient. This consider the steepness of the graph, of the line that you're given. We talked about that. So that is -5 plus 7, minus, that's a plus, over 7, minus, that's a plus again. So this was going to be 1/5, and it's a positive, like I said. So from the gradient of SR, that we have, this is where we are going to calculate now alpha, which is the angle of inclination. So alpha being arctan of the gradient that we calculated, which is 1/5. This means we are going to have something like this, arctan of 1/5 like this. That was going to be 11,3. So this is 11,3 degrees. So if this alpha here is 11,3 degrees, the angle that is between this line and the x-axis as we consider according to our understanding, we are going to see that the angle theta, which is the one between our x-axis and the line, this line that we had before, which was SP. It is a combination of this alpha. It is a combination of alpha and the angle that we want to calculate, which is the angle, this angle of PSR that we are given. So now to calculate our angle PSR, we can simply find the difference there. So our angle PSR is simply going to be the difference. This angle covering from here up to the x-axis there, which is extending everything, which is 81. So that was 71,6. Sorry, the one for the line SP. You consider from the line SP 71,6 minus this between this line, this one. We do not need this on our angle, so we have to remove this piece here. What is that piece of angle that we have? It's 11,3. You do not need this. The two, this angle and this angle combined, they add up to give this one. So that's why we have to remove from what? From 71,7. So therefore, our angle PSR in that case, if we were to subtract the 71,6 minus 11,3, that was going to be at the end 60,3 degrees. All right, so that's 60,3 degrees at the end. So these are the typical questions that you might have. You just have to consider many questions, and also we are going to have our typical exam questions and see how do they ask. But when it is like this, yeah, it can extend. Sometimes it can extend where you need to stretch yourself as much as you can. So be careful how you answer these typical questions. You just have to relate your basics of the shapes, parallel lines, triangles, angles on a straight line, and so forth, because this is about an angle. So those shapes are also should be put into consideration, and also the properties of a straight line, they must be put into consideration also.